Okay, everybody, welcome to the last video of 6.1, Properties of Exponents. Our essential question is the same: how can we write general rules involving properties of exponents? However, in today's video, we have 3 learning objectives. Our first learning objective is to learn and understand the power of a power property. Our second learning objective is to learn and understand the power of a product property. And our third learning objective is to learn and understand the power of a quotient property. So let's dig into learning objective 1, power of a power property. So again, we see here one of these charts. The first line is filled out for us. So let's go ahead and actually analyze what this is saying. In our original expression, we have 2 squared, and then that power itself is raised to the power of 4. So if we ask ourselves, what does this really mean? This means I'm taking 2 squared and I'm multiplying it to itself 4 times. So I get 2 squared times 2 squared times 2 squared times 2 squared. But then I can interpret this even further and ask myself, well, what does 2 squared really mean? Well, that's 2 times itself twice. So for our first 2 squared right here, I have 2 times 2. For our second 2 squared, I have another 2 times 2. I have a third, so here's another set for 2 times 2. And then finally a fourth 2 squared, so that's another 2 times 2 at the end. And if I were to go ahead and count how many of these 2's I have here, I would see I have 1, 2, 3, 4, 5, 6, 7, 8, which means that I can write this original expression, 2 squared to the 4th, as 2 to the 8th power. Okay, so we're trying to find a pattern here. I'd like you to pause the video, do the next 2 lines, and see if you can come up with that pattern. Okay, hopefully at this point you have filled in the last 2 lines. Let's go ahead and do it together now and see if you got it correct. So my original expression for the second line is 5 to the 5th power, all raised to the 3rd power. So that means I need 5 to the 5th 3 times. There it is. Oh, hold on. 5 to the 5th. 5 to the 5th times itself 3 times. I'm going to expand it even further and write it out as each 5 to the 5th. So for my first 5 to the 5th, I have 5 times 5 times 5 times 5 times 5. Then I'm going to move on to my second 5 to the 5th power, which is another 5 times 5 times 5 times 5 times 5. And then my last 5 to the 5th will give me 5 times itself, another 5 times. If I count all of these together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I can see that I can rewrite this 5 to the 5th, all to the 3rd power, as 5 to the 15th power. And the last one, I have x cubed, all raised to the 4th. So I'm going to have x cubed times itself 4 times. And then if I expand it even further, I will get, for this guy, x times x times x. For this guy, x times x times x. For this guy, x times x times x. And then finally, one more set of x times x times x. And if I count them all up, I get x to the 12th. So my question is, how can we find a pattern between the exponents in the original expressions column and the exponents in the single powers column? Well, let's look here. I'm going to erase this just to clear it up a little bit. My exponents for my first line are 2 and 4. Well, 2 times 4 just so happens to give me 8. My exponents in the original expression for the second row, or second row is 5 and 3. 5 times 3 gives me 15. And then 3 and 4 in the third row, 3 times 4 gives me 12. So if I'm trying to find a pattern, I would have to say that the pattern I see is that when I multiply the exponents on the left, I get the exponent on the right. So power of a power property tells us that a to the mth power, all raised to the nth power, is a to the m times nth power. So basically, if I have a power, which again is an expression written with an exponent, raised to another power, multiply the exponents together. And also note that you're going to keep the base. Okay? And that's power of a power property. Moving on to learning objective 2, we have power of a product property. So again, let's take a look at this chart that we have. Our original expression gives us 2x to the 4th. So that's 2x times itself 4 times. Well, if I rearrange some terms, I can put all of my coefficients together, meaning all of my 2's together, and put all of my variables together, meaning all of my x's together. And what I really have now is 2 times itself 4 times, which is 2 to the 4th here, and then x times itself 4 times, which is how I get this x to the 4th here. So again, based on that example, pause the video, do the last 2 lines, and then we'll come back together and see how you did. All right, hopefully you filled in those last 2 lines. Let's do them together now and see if we get the right answer. My second line gives me negative 4a cubed. So I'm going to have negative 4a times itself 3 times. I'm going to put all of my coefficients together, so I get 3 negative 4's, and then all of my variables together, so I get 3 a's. And just remember, the operation here is multiplication, so we are going to keep that operation. Negative 4 times negative 4 times negative 4 times a times a times a. And when I rewrite everything like this, where the coefficients are together and the variables are together, I can see that I really have negative 4. And I want this in parentheses because my negative is part of what's getting multiplied. So I have negative 4 cubed times a cubed. Perfect. And then let's take a look at line 3. I have x cubed y squared to the 4th. So that's going to be x cubed times y squared 4 times. There we have it, x cubed times y squared 4 times. I am going to take all of my x terms and put them together. So I get 4 of those. And then I'm going to take all of my y terms and put them together. So I will have y squared times itself 4 times. So what I see that I have here is x cubed to the 4th, because I have x cubed times itself 4 times, and then times y squared to the 4th, because I have y squared times itself 4 times. However, if we think about the power of a power property that we learned, that was learning objective 1, I know that I can multiply, don't know why that keeps happening. I know that I can multiply my exponents here, because any power raised to another power, multiply the exponents. So really, I have x to the 3 times 4, which is 12, times y to the 2 times 4, which is 8. And that's my final answer. X to the 12th, y to the 8th. So if we're looking for a pattern here, power of a product property, let's see what happens. Let's do a quick recap. Here, I had 2x in parentheses to the 4th. That turned into 2 to the 4th, x to the 4th. So my first number got the exponent, and my variable got the exponent, almost like the exponent was distributed. Let's see if that happens again here. I have negative 4a cubed. Well, it got me to negative 4 cubed, a cubed. So again, it's like that exponent gets distributed. Let's see if that happened here. I have x cubed y squared, all to the 4th power. That turned first into x cubed to the 4th, y squared to the 4th. So this 4th power got distributed to each term. And then using power of a power, I just simplified that to x to the 12th, y to the 8th. So that means the pattern I see for power of a product property is any base a times b raised to the mth power can be rewritten as a to that same mth power times b to that same mth power. So in words, we can say for any product, meaning two things being multiplied together, for any product being raised to a power, distribute the exponent to each term, meaning the a gets an m and the b gets the m. And that's power of a product property. And so we have one more, which is power of a quotient property. No chart here, but I do have an example, and I want to think about 3 over 4 squared. So we've looked at things that have the same base. This is quotient, power of a quotient property. I'm sorry. This is power of a quotient property, but we've seen a to the m over a to the n, and we knew that that meant we took a to the m minus n. Here, though, we don't have the same basis, so we know that it's not going to be something like that. Also, my fraction in itself is being raised to the second power. It's not that each term is being raised to a power. However, if we think about learning objective 2, power of a product, we distributed this mth power. So what I want you to remember is that when we're dealing with something like this, it's going to follow the same pattern. It's just that instead of multiplication, we're dealing with division. But in both circumstances, I'm going to distribute that exponent to both the numerator and the denominator. So 3 over 4 squared is going to equal 3 squared over 4 squared. So in other words, for power of a quotient, if I have AB in parentheses raised to the nth power, I can distribute that power and rewrite it as a to the nth power over b to the nth power. So again, if I have a quotient, meaning a fraction or two things being divided, distribute the exponent to the numerator, or to the term in the numerator and in the denominator. And that's it. So this completes all of the properties of exponents that we're going to be learning. This closes out section 6.1. So don't forget to get a good grasp on all of them, because we are going to need all of them, not only for the upcoming quiz, but also as we move on to 6.2. Also, please don't forget to bring in your notes and do the Google form.